There again, keeper of the clock here at Trinity. I've just wound the clock. It's just after 12 o'clock, and I'm going to show you a couple of things here in my room in college. I've got well, there's a clock up on the wall. That's just there's nothing particularly special about that, but it's quite fun to have. But what I do have here is a 1904 clock, which is made by exactly the same company, Smith of Derby, that made the clock, the Trinity clock. Now, I'll tell you a little bit more about this as time goes on, but what I wanted to tell you is something which is quite fabulous, which is about temperature compensation. Now, there's a pendulum which you can see swinging away. There's the bottom of it, and the top of it is up there. Now, the nice thing about this pendulum is, well, temperature compensation. Let me tell you, the first thing I'm going to do is just to unhook the pendulum from the top. Maybe if I put the camera down, it'll make it easier. You'll be able to see better what's going on. I'll put it down over here. What I'm going to do is I'm going to unhook the pendulum from the top and then lay it down on the ground. Right, I've unhooked the pendulum and laying it down on the ground. Now, the nice thing is that it all comes apart. So for instance, if I remove this pin from here, I can take the suspension off. So that's the bit that causes the pendulum to swing. But the temperature compensation is just fabulous. So what I've got here is a lovely old wing nut, which I can take off like that and remove that. I can remove the bob. There's a pendulum bob. That weighs, oh, it's heavy. That weighs maybe 30 kilograms or something. Maybe not that much, but it's heavy. Now the clever bit is in here. If I take out this other pin, tap it out. Whoops, coming out. The pins are tapered, which means that you've got to tap them the right way. Which way? Oh, I was doing it the right way to start with. There we go. Right, I've taken that pin out. There it is. If we look inside, what we find is that there's a zinc tube. If we look inside the zinc tube, we find a steel rod. So we've got a steel tube on the outside, a zinc tube in the middle, and then right in the very middle is another steel tube. And the idea is that the steel goes down, zinc goes up, steel comes down, and zinc has got a 2.5 times greater expansion coefficient than steel. So there's 2.5 times as much steel going down this way as there is zinc going that way. The zinc expands with temperature 2.5 times as much as steel, so that means the pendulum bob stays the same length. It's just fantastic. It was designed by Harrison, famous for the solution of the longitude problem. And so here we have a temperature control pendulum. Now what's fantastic about it is just how easily it all goes together. Of course, famous last words. I put all this back, more or less in reverse order, the way I put it in. Let's see if I can remember which way all this goes. I think it goes like that. And that goes like that. this pin back in, the one that I took out. With any luck, that will tap back in. Put the heavy weight back on. Put this back on. Put the wing nut back on. Oops, what's that on that? That's right. Right, then put the suspension back on. The pin back into the suspension. Lift the whole thing up.